Hello friends, today we are going to see new HackerEarth challenge, which is live challenge, Guardian Code-A-Thon Hiring Challenge ETL Chronicles, in which we are going to solve a DSA question, which is this question, the final state. In this question, you are given a 2D array A of size n cross m. The array contains only two values, 0 and 1. All the zeros are fixed, whereas all the ones are active for unit time. The active cells with value 1 perform the following operation at any time t. So what we are given? We are given a 2D array or a matrix in which elements are either 0 or 1. One value refers a active cell at initial time t and 0 values refers inactive cell. Then we have to perform the following operation on the active cells. Find the neighboring cells with the value 0 at the time t minus 1. In a unit time, what we have to perform, we have to find all the active cells, then all the neighboring cells of that active cell, we have to change it from 0 to 1 by doing XOR with 1 in this neighboring cell. This cells with value 1 becomes inactive. Now the initial active cell become inactive after time t, and new cells which get value 1 become active, and new cells which is just become the value which is just become 0 to 1 is become active, and previous value of 1 become inactive. And then we have to find the final state of 2D array after all this process. So XOR is a simple XOR operation. Neighboring cell is common side like top down, bottom, top bottom, left right cells. So in this given example, we are given 0 1 1 0 0 0 0 0 0 1 1 0. So we have this array in which it has 3 rows and 4 columns. So we can visualize this as 0 1 1 0 0 0 0 0 and then 0 1 1 0, and we have number first row, second row, first column, second column, third column and fourth column, and here this is first row, this is second row, this is third row. So initial at time t equal 1, we can say that t equal 1, we can say that we have this cell 1 comma 2 is active, and 1 comma 3 is active, and 3 comma 2 is active, and 3 comma 3 is active. So what, and now we can write all the neighbors which is inactive or 0. So neighbor of 1 comma 2 is 1 comma 1 and 2 comma 2, 1 comma 1 and 2 comma 2. Neighbor of 1 comma 3 is 2 comma 3 and 1 comma 4, 2 comma 3. Neighbor of 3 comma 2 is 3 comma 1, 2 comma 2, and neighbor of 3 comma 3 is 2 comma 3 and 3 comma 4. So cell 1 comma 2 is 1, and its neighbor is this 0 and this 0. So this one do XOR with this cell and this cell. So it will change 1 comma 1 and 2 comma 2 is XOR 2. If it will do XOR with 1 comma 1, it will become 1, and if it will do XOR with 2 comma 2, it will become 1. Now 1 comma 3, if 1 comma 3 do XOR with 2 comma 3, 2 comma 3 is this cell, so it will become 1, and 1 comma 4, 1 comma 4 this is 1, and it will become 1. Now 3 comma 2, 3 comma 2 do XOR with 3 comma 1, 3 comma 1 this one, and 2 comma 2. Now this cell 3 comma 2 XOR with 2 comma 2, now it become 1 XOR 1 equals 0. And now last one 3 comma 3 do XOR with 2 comma 3, 2 comma 3 this one, so now this become 0, and now 3 comma 4 this become 1. So at time t equals to 1. Now at time t equal to 2, what all active cells we have apart from initial cells 1 comma 2, 1 comma 3, 3 comma 2, 3 comma 3. Apart from these cells we have 1 comma 1 is active cell now, because it is newly being active, and then 3 comma 1 is new active, and 1 comma 4 is being new active, and 3 comma 4 is being new active. Now this 1 comma 1 has a neighbor 1 comma 2, 1 comma 2 is its neighbor, and 3 comma 1 has a neighbor is this is 2 comma 1, sorry, and this is also 2 comma 1, and 3 comma 4 has a neighbor 2 comma 4, and 1 comma 4 also has a neighbor 2 comma 4. So firstly 1 comma 1 make it 1, then 3 comma 1 make it 0, then here is also 1 comma 4 make it 1, then 3 comma 1 is make it 0. So final matrix state will be this one, where we have no active element now. This is our final matrix state or array state, and this is our answer. So from all this processing, what we understand? We understand that like from this one, like 1 comma 1 and 3 comma 1 both will do XOR on 2 comma 1. So we know that if what is XOR property? XOR property, because we have only two elements 1 and 0, 1 and 0, we have two cells, two numbers, and we have to do XOR in this. So if we do XOR, if initial element is 0 and we do even times XOR with 1, so our final answer will be always be 0. Example, 0 XOR 1, its answer 1, then again we do XOR with 1, then its answer becomes 0. So if we are doing 0 XOR with 1 even number of times, then final answer will be always be 0. And if we do 0 XOR odd number of times with 1, then our final answer is 1. Example, 0 XOR 1 is only 1, or 0 XOR 1, its answer 1, then we do XOR with 0, XOR with 1 again, so its answer becomes 0. Now again we do XOR with 1, now its answer become 1. So we did 3 times XOR, initial 0, then its answer with 1, then its answer with 1. So final answer is always be 1. So what we understand, if any cell which is 0 and is inactive, and its neighbor who changes its state is odd, then it will become 1, and if it is even, then it will become 0. So now we understand the question. Now we are going to the implementation part of this question. So how we think, how we approach this problem, what should be our thinking process. So if we see this question, so in this question what is given things, we have a matrix in which we have zeros and ones, and 0 is inactive and 1 is active. So initially we should know all the ones, its index, like its row and column, then only we can find its neighbor. So, and what should be our thinking process, what should be our time complexity if we try to approach this problem. So in the best case, we want to do traversal, we have to check every single, at max we have to check all the cells of this given matrix. So in best case we need O of n cross m time complexity, that is traversal of whole matrix. So in best case our best time complexity will be our best time complexity will be O of n cross m. So now we have to think the approach so we can find the solution in O of n cross m time. So first what we can do one traversal of whole matrix, and we can find the position of all the ones, and we can store it any set or list or queue. So if we find that, then we have all the initial active elements indexes. So this will take O of n cross m. Now this is initial part, and now we can think in terms of BFS, breadth first search type of approach. So initially we have all the elements who is active. Now we can pop one by one element of this initial list, which has all the active elements. And one observation we have here, that initial list, like in BFS what we can do, we can pop elements one by one, but here we need to maintain two separate lists. Like one list should do one operation completely, then we can start with another list. Example, like in time t1 we have some active elements, and those active elements process are interrelated, because we know that like 2,2 and 2,2 affected by 1,2 and 3,2. 3,2 also affect 2,2 and 1,2 also affect 2,2. So we have to maintain some kind of process. So all this initial active states will process at the same time. Then again at t equal to 2, result of newly active states process at a single go. So now we can start writing solution of this. So what we have this as input parameter. Now def states Here we are passing n comma a, and this is our main function for processing. Now we have to create one list which will store the answer. And we can create one store kind of thing. So with the help of that, we can store the initially active states. So we are taking it set. I will explain you why we are taking it as a set, not a list. So now we are running one loop from I equal 0 to n and j equal 0 to m, and we are checking if a of ij is 1. If it is 1, then we are storing some value, where value is so we are storing this as an index. We are storing it as a string. We are storing indexes as a string. We can store it as a tuple or a list. That is also fine, but here we are using string for storing the indexes. Now we can traverse this until we have a store. Now we are creating two variables, row and column, for finding the neighbors. So 0 0 1 and -1. Here we are -1 1 0 and 0. And now we are populating answer of row and column equal to 1 because it is initially active. So we have to populate it as 1 before we have to do any process on this on the indexes, all those neighborhood thing, because in neighborhood we are checking whether it is 0 or not, and if we are not populating it initially as 1, then it will create problem when we are going to check whether its neighbor is 0 or whether its neighbor is 1 or not. So now we are checking, we are running one loop, and here we are finding the same thing, and here if we for every I change 4, we are finding new row should be row plus row of k, and new column equal column plus all of k, and we are checking if new row is greater than equal than 0 and new row is smaller than n, and new column is greater than equal than 0 and new column is smaller than m, because new row and new column should be in the matrix. That's why we are checking this condition here. And now we have to check again if and answer of new row and new column equal 0, then only we are making this neighbor active, new, or storing this neighbor. And for that we are creating new store, we are creating new set. We are not storing in the same set or same variable store, because we know that we have to, because we are accessing this, we are running one loop here using the same variable. If we are populating the same variable, then it will give us error. That's why we are creating new variable, new store, and we are populating that variable here. And here we are creating new row plus this plus string, new column, and we are, and at last we are modifying store to new store. After all this, we are returning our answer. So let's call this main function at the bottom with parameters n comma a, and we are storing its answer, and then we are printing for answer. So we are getting some error here. What does, okay, so we forget to put comma. So here we are getting wrong answer. We need to debug why we are getting wrong answer here. So our expected answer should be 1 1, then it will be 1 1 1 1, then it should be middle row should be 0. So now we are checking here, we are taking one variable answer in which we are storing answer, and we initializing it. Then we are taking another variable store, which is a type of set. Then we are running one loop. In this loop we are checking if a of I j is 1, then we are storing ij value or indexes in variable value, that is a type of string, and then we have to populate the store, and we have like update the store with this value. Now we have a row and column. So here we forget one thing, we have to like wrote those logic which we earlier discussed during question discussion or during example, that if this value present in new store, then what we have to do, then we have to remove that value basically. Why? Because if neighborhood that a particular index is a neighbor of 2 active cells, then it means like its final state will only be 0, or if it is neighbor of even number of active cells, then its final state is always 0. So we need not to add that in a new active state. So if it is already present, it means there is an active state. Then if we process again someone, then we can remove it this way. If active number of neighbors of any particular cell is odd, then we can add that cell one time in new store. If even, then we are not adding that. Yeah, we are getting right answer this time. So we can try another sample example for testing purpose. Let me let take as example as number of rows is 5, number of column is 1. Here equal 1, then 0, then 1, then 0, then 1. So like 1 0 1 0 1. So this 2 1 initially this 3 1 is active, and this one and this one, this 0 is a number of this 2, and this 2 will make it 0 only, because 0 XOR of even ones, then it final state is 0, and 0 this 0 also be 0 only. So we got the right answer if we make it 0, or if we make it 0 and here we make it 1, then this one make this 0 1, this one make this 0, and this last 0 1. So we are getting all ones. Yeah, want to explain you again how this code works. So what we are doing, we are creating one answer array, then we are taking one variable store, which is a type of set. Why we are taking the type of set? Because of line number 30 to 27, because checking whether the element is present inside the set or not. In Python it is O of 1, amortized O of 1 operation, and then adding new element and removing existing element is also of O, amortized O of 1 time. Or anything else, any other data structure apart from dictionary, if we are using list tuple, then we have to traverse it, and it will take O of n time. So it will unnecessarily increase our time complexity. So that's why we are taking here set. Then initially in one go, what we are doing, we are storing all the active cells, and then we are creating two variable which for traversing the neighbors, like top, bottom, left, right cell of any cell. Then here we are creating new store variable, because we do not want to add newly active cells in previously active cells array, because previously active cells works together and newly active cells works together. That's why at last we are like replacing current active cell to new active cell. And here what we are why we are using two loops, loop number 13, and then loop present at line number 13 and loop present at line number 18, because in answer array we have to pre-populate initially active cells. Why we are doing so? Because if we are not populating, and if we are populating this answer array in this, then there are some cells which is neighbor of currently processing cell, which is active in current process, but because we are not populated here previously here, so it is showing it is 0, and now we are again populate it, and we are adding it in newly populated cell. That's why it will create confusion, and it will give us wrong answer. That's why we are populating here instead of there. I will show you. Instead of there, I can populate here, then you can find that it will give us wrong result. So for this question it is giving us right, but for another examples, like for this example, here we are getting the wrong results. So as we discussed, its total time complexity is n cross m, and we are getting right result. Thank you all. Please subscribe. If you like the video, please do subscribe the channel and share this video with your friends who are currently studying in first or second year, so they can get the idea how we are approaching the current challenges problem on HackerEarth, and they can get the opportunity of internships and replacement offers initial in their third year and fourth year. So it is the best time to do practice. And if you like this video, please do subscribe, share and comment, and also give thumbs up. Thank you all.